It's like finding out all your favorite books are secretly part of one epic, interconnected story. The Langlands Program? It's the hidden language weaving through mathematics, geometry, and the quantum world. A language so profound, it might just bridge the gap between our understanding of numbers and the universe itself. All right, grab your coffee. Or tea, I won't judge. And let's dive into what could be the most breathtaking, mind-stretching concept in modern mathematics. Hey, welcome back to Hyperfocus. If you're here, you're exactly the kind of person I adore. Someone who craves depth, someone who looks for the stuff that's beyond the surface. And if you're new, hi, I'm Olympia. I won't guarantee answers, but I promise you we'll ask the wildest and most important questions. Let's tackle the Langlands Program today. It's been called the Grand Unified Theory of Mathematics. I mean, who doesn't get excited about that? So, what is the Langlands Program? Picture a gigantic universal Rosetta Stone for math. Over here, you've got number theory, a field obsessed with the properties and relationships of whole numbers, primes, things like that. In a totally separate realm, there's geometry and even concepts used in physics. These worlds look totally unrelated on the surface, but Langlands suggests they're not. Instead, they're deeply connected. It's like finding out Morse code and hieroglyphics describe the same thing, just in different formats. Trippy, right? Let's break down how this actually works. Imagine you're trying to solve a math riddle. Say, you're hunting for patterns in prime numbers. Langlands posits that clues to your riddle may not even lie within number theory itself, but within geometry. That's insane, because it's like solving a puzzle by looking at a completely different puzzle that somehow mirrors it. This concept of reciprocity is one of the program's most beautiful aspects, a correspondence or reflection between different kinds of mathematics. For example, modular forms. Don't worry, these are like shapes, but in the mathematical sense, turn out to be code breakers for problems we thought belonged solely to number theory. I mean, how cool? But hold up. The Langlands Program doesn't stop at connecting math. It dives into physics, linking number theory to quantum mechanics. How? Here's one jaw-dropper. Did you know Langlands-inspired methods are used in string theory? Yeah. This seemingly esoteric piece of math has real-world implications in figuring out how fundamental particles interact, or maybe even why space-time stretches or curves the way it does. Listen, if we could even begin to untangle that, wouldn't it mean we're closer to decoding the universe? Of course, every grand theory has its debates. There are camps of mathematicians and physicists who embrace Langlands with open arms, while others find it too obtuse or unproven in its broader implications. It's rigorous. Even the best minds working on it take years to solve even incremental problems. There's also an ongoing debate about whether Langlands can guide physics practically, or if it remains just math. But remember, so did Einstein's equations before the GPS in your pocket was a thing. Here's a question to think about. Could it be that math isn't just a reflection of our universe, but the actual scaffolding it's built on? Think about it. Why should prime numbers, or abstract shapes like modular forms, predict outcomes in quantum fields? It's not just a curiosity, it's the kind of enigma that keeps one's brain buzzing. So where's this all going? Imagine cracking the Langlands Program fully. It could rewrite our understanding of physics, giving us new tools to tackle questions about dark matter, the Big Bang, or even time itself. It's like being handed glasses that let you see reality's blueprint. And you're in on the discovery. It's unfolding now, not 2 centuries ago. How amazing is that? Before I wrap up, I want to ask, what's your take on this intersection of math and reality? Does it thrill you, confuse you, or frankly, scare you a bit? Let me know in the comments. I read them all because Hyperfocus is about growing this incredible, curious crew together. And hey, if you've enjoyed this, liking and subscribing means the world to me and the people nerding out alongside you. So, until next time, stay hyper-focused, and may your reality always align with the most exquisite math of existence.